Hello class, this will be part 2 of flow networks. In this video, we're going to learn how to find out what is the maximum flow by performing the minimum cut algorithm. Now if you recall from our last video, I said that it's difficult to find out what is the maximum flow when you've got network diagrams that have many edges and many vertices. So an easier way to do this is by performing the minimum cut algorithm. In this algorithm, it states that the maximum flow of any network will be exactly equal to the minimum sum of a cut. So let me explain what a cut is. So what a cut is, it's an imaginary dashed line that we draw on the network, and essentially what it does is it cuts off or disconnects all the flow between the source and the sink, and it divides the graph into two parts. So in this example over here, this over here is going to be my source, and that over there is going to be my sink. Now, if I draw a cut correctly, what it will do is that it will prevent the water flow or the income or the material from reaching the sink in this case. So one of the ways that I could draw a cut is by drawing a line like this. And by performing a cut like this will prevent any flow from reaching the sink in this case. So this is a valid cut. Another example of a valid cut for this particular diagram is shown over here. So if I do it like this, notice again that this will prevent any of the water flow from reaching the sink. So that's another valid cut. An example of an invalid cut will be something like this. In this particular example up here, notice that although it disconnects all the flow from this route, it's still possible for the water flow to reach from the source to the sink in this case through this particular pathway. So in this example of here, we say that it's an invalid cut. And in this video, it's really important that you know how to draw a cut correctly in order for you to find out what is a maximum flow. In order for you to draw a valid cut in any flow diagram, it might be useful to draw two horizontal parallel lines that are found above and below the network. So you can draw them like this. Afterwards, what I want you to do is I want you to think that you're in a car found in the bottom line, and your objective is to move from the bottom and reach the top horizontal line. And in doing so, what you've done is you've drawn a cut. So an example of that is by going through in this manner over here. So that is an example of a cut. However, as shown by the previous slides, it is possible for a flow diagram to have many cuts. So another example of a cut moving from left to right is like this over here. So you could draw a cut like this, and this will disconnect all the flow from reaching the sink in this case. Our ultimate goal is for us to find out what is the maximum flow, but in order to do so, it is critical for you to draw as many valid cuts as possible, moving from left to right in a given network diagram. So I want to quickly fast forward and show you all the valid cuts that you can make for this particular diagram. In this example, you can see that there are 6 valid cuts that you can make, and one of these options will ultimately tell us what is going to be the maximum flow for the diagram. As you can see, it can be quite messy illustrating all the valid cuts there are on this particular flow diagram. So it's really important that you do it in a very systematic way where you draw all the cuts moving from the left to right. Once we have illustrated all of these cuts, I'm going to now denote and represent each of these cuts by using a letter as well as a subscript. So in this case over here, I'm going to use a letter C to represent cuts, and the numbers 1, 2, 3, 4, etc., etc. to list down all of the cuts that are possible. Now that I've done this, in order to find out what is my maximum flow, I first need to find out what is the value or what is the capacity of the cut, and this essentially is the total flow of the edges that I cut. In this algorithm, what we want to do is we want to find out what is the minimum cut, and that is essentially the cut with the lowest weight or the lowest cut capacity, and in doing so, this will tell us ultimately what is our maximum flow. When you're adding the edges to find out what is the capacity of each of the cuts, I do want to point out that the direction of the flow needs to be considered when finding the capacity. It means that depending on the arrow of each of the edges, some of the edges you add, some of the edges we actually ignore when you're trying to find out what is the capacity of the cut. An easy way to think about this is by referring to the diagram down below. In this example over here, if the edge is moving from left to right, what you do is you want to include them to the total weight or capacity of that cut. However, if the arrow goes from right to left, we ignore that value and it does not contribute to the capacity of the cut at all. Let's look at an example so I can show you what I mean by this. Let's first start off by calculating what is the capacity of cut number 1. So for cut number 1, what you want to do is, again, use the same analogy where you're driving a car from the bottom line. So in this case, if I start from the bottom and I pass through this edge over here, because the arrow is going from left to right at that particular edge, I'm going to include that value. So I want to include 1200. And when I therefore pass through this particular point over here, notice that the arrows are again moving from left to right. So I'm going to therefore include both of these values over here to the total capacity. And in doing so, my final answer is going to be 3400. And I'm going to do the exact same thing for all the other cuts. So for cut number 2, if I start from the bottom, again, notice over here that this is going from left to right. So I'm going to include 1200 into my calculation. When I reach at this particular point, similarly, the arrow is going from left to right. So I'm going to include that value there, which was 1500, as well as 1000. And therefore my answer is going to be 3700. For cut number 3, similarly, because the flow is going from left to right, I'm going to include 1200 to the overall capacity. But when it reaches this particular point over here, notice that the flow in this case is going from right to left. And because it's going from right to left, we do not include this value of 600 at all. If you're wondering why we do not include that value at all, it's because we've kind of made a cut at this particular edge already. And by cutting that flow, that's the reason why we do not add up this value at all, because it won't contribute to anything. Nothing actually flows through that edge anymore. Let's continue our journey. So if the car is now in this particular position over here, notice that the flow is moving from left to right. So I'm going to include the values 400 and 1000, as you can see over here. And to therefore find the total capacity, I'll just add up these values, and therefore the capacity of cut 3 is equal to 2600. For cut number 4, the flow is moving from left to right, so I'm going to include 600. Similarly, when I make a cut through this edge over here, notice that the flow is moving from left to right, so I'll be including the values 600 and 1500, and when it reaches this point, I'll also be adding 700 as well. So therefore, this has a capacity of 3400. As you can see, it does get quite repetitive, so at this particular point, because it does pass through this edge and it moves from left to right, I'll be including 600, 400, as well as 700, and that has a capacity of 1700. And for our final cut, notice that all of the flow moves from left to right, so I'll be adding 600, 400, and 1000, and therefore that has a capacity of 2000. Now that I've calculated what is the capacity of each of the cuts that I've made, what I want to do now is locate what is the minimum cut, as this will tell us what is the maximum flow. So in this example over here, the minimum cut is equal to 1700, so that was cut number 5. So therefore, our maximum flow for this particular network diagram will be equal to that value. What I'd like you to do now is I'd like you to now have a go to see if you could find out what is the maximum flow by performing the minimum cut algorithm. So have a go for this question and we'll go through the answers together. One of the cuts that you can make is this one over here, so I'm going to label that as C1. So if I was to find out what was the capacity, because both of the flows are moving from the left to right in this case, I'll be adding up those two values. So C1 has a value of 19. To find out the value of cut number 2, we will add the value 11 in this case, because it moves from left to right again. However, when you go through the second edge over here, because the flow is moving from right to left in this case, we do not include the value 5 to capacity at all. But when it does go through the third edge, the flow does move from left to right. So therefore, we'll be adding the values 11 and 3 to find the capacity of cut number 2. So therefore, that has a capacity of 14. Cut 3 can be illustrated like this over here. So to find out the capacity of that, we'll again add the values 11. To go through the second edge, notice that the flow is moving from right to left in this case, so we do not include the value 3 at all. When it goes through the third edge, because the flow is moving from left to right, we will be adding the values 5 as well as the values 3. So therefore, the capacity of cut number 3 will be equal to 14. We have now found out all of the cuts that can be drawn going through this particular edge over here. So now to find out cut 4, I'm going to be going through this edge over here. So cut 4 could be represented like this. To find out the value of that, notice that all the flows are moving from left to right. So therefore, I can just add up all of these 3 values. So cut number 4 has a value of 12. Cut 5 can be represented like this. In this particular example over here, I can add the values 1 because it moves from left to right. I could also add the values 3 because it moves from left to right. But in this case over here, I cannot add the value 5 at all because the flow is moving right to left. But I can add the values 3 in this case because again, it moves from left to right. So by adding up those 3 numbers, the cut number 5 has a capacity of 7. And the last cut that you could actually draw for this example over here is like this. So therefore, in this case, because all the flow is moving from left to right, I could add up all of those 3 numbers, and therefore cut 6 has a capacity of 9. To now find out my maximum flow, we just find out what is the minimum cut. So in this case over here, the minimum cut is 7. So that's going to be our answer for this question. The maximum flow is going to be 7. By now, you should be able to find out what is the maximum flow by performing the minimum cut algorithm. I'd like you to now please answer questions 1, 2, 3, and 4 from exercise 15A to get further practice. Thank you for watching this video, and I'll see you guys again in the next video. Bye.